Yes, I think we are live. Um, hey guys, welcome to our brand new show, The Code Rush, where we help developers understand DevOps and cloud native concepts with live demos and practical examples. I'm your host Pavan, and I have with me Om Prakash. We call him OP as a co-host to manage the show. Hey OP, how excited are you?
Hey, Pawan, and everyone. I'm absolutely thrilled about the Code Rush. I think it's an amazing chance for everyone to sharpen our coding and DevOps skills and take our skill set to the next level.
Sure. So OP, who is our guest today, and what are we going to talk about?
So, yeah, in today's show, we are going to discuss a necessary topic managing cloud cost. And our guest for today's show is Ravi, the product owner for the CCM module at Harness. He's also an inspiring entrepreneur with extensive experience in e-commerce, cashback, cloud ops, and healthcare, having co-founded companies such as Pennyful, MediRupee, and Lightwing. So, hi Ravi, welcome to the show.
Hey, OP. Hey, everyone. Glad to be here.
Nice. Hey Ravi, we're really excited to have you here in the show as our first guest. And yeah, so managing cloud costs is very important for any organization today. And there has been a lot of talk in the industry about how to manage the cloud costs. And today, cloud practitioners are very eager to know and learn some cool tricks and practices to manage their cloud costs. Well, we have an expert here who knows a lot about cloud cost management, and he's been working on such products for last several years. Ravi, so my first question to you is, how important it is to manage cloud costs for the companies?
Yeah, that's a great question, Pawan. So, first of all, I want to start by congratulating you and OP on this new show. and
Thanks.
coming to the question, so how important is it to manage cloud costs for companies, right? So, if we really look at it, companies need to do two things, ideally both things well. So they need to make more money and they need to spend less money, right? Now, cloud costs are typically one of the highest costs, cloud costs, infrastructure costs for companies after people costs. So the easiest way is to manage cloud costs effectively and make sure that the companies are spending only as much as they should be and they're not overspending on it, right? Now, essentially managing cloud costs means that in a very simple terms that you have more money on the table, right? And in this critical environment, we've all seen what's happening with things like the Silicon Valley Bank, the Signature Bank, and so
Hmm.
on. So we are in uncertain times from a market condition standpoint, to say the very least. And so it's most critical today to effectively manage costs and not overspend. And what this essentially will allow you to do with having more money on the table is to reinvest in the projects and programs that are important to the company, maybe even retain talent, right? And so the best way to effectively manage cloud costs is through what at Harness we call as intelligent automation. So what this does is
Hmm.
it takes away most of the manual effort involved. And I'll give you an example of a customer, right? So they've actually implemented automation to do various things, like from an optimization standpoint, including automatically shutting down any idle cloud resources that they have, automatically right sizing the containerized workloads, and automatically cleaning up unused resources that they don't use. And this was like a fairly straightforward one-time setup. And today they're reaping that benefits of those hard dollar savings every day, every month, by significantly cutting their cloud costs and their cloud bills. And so it's extremely important to even specifically today to manage cloud costs efficiently.
Yeah.
So, yeah,
OP.
without proper cloud cost management, organizations may end up spending more money than necessary on cloud services, resulting in an increase in operating cost. I think that's a valuable insight. So, what are some adverse effects if they don't manage their cloud cost?
Yeah, so the most obvious adverse effect is of not effectively managing cloud costs is that it leads to what we call as cloud waste, right? So cloud waste is essentially companies paying for cloud resources that either they don't need or that they don't use. And having a lot of cloud waste simply means that you could have invested that wasted cloud spend into your core business, right? Into projects and programs that are important to you. And like I said, maybe even retaining talent in this kind of market condition. But instead, you end up paying that to your cloud provider, to AWS, Azure, or GCP, which ideally should not be the case. So that's That's really the typical adverse effect of having wasted cloud spend, if cloud costs are not managed effectively.
Got it.
Nice. So, Ravi, since there are many roles in the DevOps, in a company, in a DevOps, when it comes to DevOps, like cloud practitioners, architects. So, whose responsibility it is to keep track of all these cloud spending in a company, actually?
Yeah, so that's a great question. Now, typically you have financial management that owns keeping track of cloud spending, right? So this could be finance, FinOps, cloud ops, but it really boils down to any budget owner. So if you own the budget for your team, then naturally you care about keeping track of your cloud costs and cutting those cloud costs. Now, this could be on the one hand engineering or DevOps, or on the other hand, it could be FinOps or cloud ops, right? Either way, I think what's most important is that developers on the ground who get asked to cut costs need to be given the right set of tooling to manage cloud costs effectively. So we call this essentially the shift left of responsibility of keeping track and managing cloud costs effectively. So overall, managing cloud costs requires three aspects of cost management pillars, as we call them at Harness. So the first is cost visibility, the second is cost optimization, and the third is cost governance. And to essentially illustrate this, I can quickly share um,
Yeah, please.
that slide here. Yeah, please let me know if you see my screen.
Yeah, it's loading. Yeah, we can see now.
Perfect. So essentially, the first pillar is cost transparency or cost visibility. This is all the features that the customers need to have a clear view of the hierarchical breakdown of cloud costs across their organization, right? Who's spending what are they spending it on, and why? And the second is cost optimization, basically all the features that they need to cut down their costs. So this could be through actionable recommendations, through automation, and so on. And then the third pillar that we have is cost governance. So those checks and balances, those guardrails to make sure that the cloud costs are where the customer wants it to be or where the company wants it to be, having done the cost visibility and the optimization. So all of these features is what is really important that we make sure gets to the right hands, and we empower the developers and budget owners to, with the right kind of tooling to be able to implement managing and optimizing cloud costs effectively.
Got it. So, could you share us some simple tricks to manage cloud cost, like some hacks that will help us to implement?
Absolutely. So the short answer to tricks that could be relevant is that it depends, right? So it depends on the cloud provider. Are you using AWS, Azure, GCP? Which services are you using? How do you consume these services and resources? But broadly, you can manage cloud costs in a few different ways, right? So the first is around the pricing of the cloud services and the resources that you consume. There are many ways to save on just that. So the exact same resources, same cloud services, just based on pricing, there are different ways you can save, either through using excess cloud capacity or through commitments, which we'll talk more about in a second. And the second way is through right sizing of resources that you consume. Now, if you typically look at it, developers, what they care about fundamentally is not cost, right? What they care about is velocity to ship things really quickly and to make sure what they ship is performant, right? So make sure that performance is protected at all costs. But a lot of times, as a result of this, we end up with what we call as over provisioned resources, meaning resources which have configuration much larger than what they typically might need. So it's also important to make sure that the configuration of these cloud resources is optimal while protecting performance. It's also efficient from a cost standpoint. And the third thing is to clean up what we call unused resources, basically resources that are not being used, which could be like often EBS volumes, elastic IPs, old snapshots, resources that are simply not used anymore, but are just still lying around and costing the company money. So cleaning that up is the third strategy. But specifically from a pricing standpoint, I'd like to quickly share another diagram here.
Yeah.
Yeah.
Yeah, we see it. Yeah.
Okay, perfect. So specifically from a pricing standpoint itself, for the same services and the same resources that you would consume, the starting baseline is the on-demand instances, right? So on-demand is essentially paying full price. As long as you keep paying it, the cloud provider is going to make sure that you have all of the resources that you need. Now, this is guaranteed from an availability standpoint, but you're paying full price. Now, if you're able to commit to usage over a period of time, over a longer period of time, then you have options of what we call as commitment instruments. So from an AWS standpoint, you have RIs and savings plans. You have similar capabilities with or similar options with Azure and with GCP, for example, with committed use and sustained use discounts. Now, what this essentially means is that you're telling the cloud provider over a certain amount of time, you are guaranteeing to them that you will use these resources. And in exchange, you're getting a significant amount of discounts or savings. Right? Now, at the lower end of the spectrum, this could be about 25-30%, up to 66 to 72%, as you can see that's listed here. Now, the levers to increase the savings from this is broadly two things. So the first one is the longer you commit to using this, between a 1 and 3 years, if you commit to 3-year usage, you get more savings compared to a 1-year commitment. And also the second lever is around the pricing options itself, where you can, for all of the commitments that you're making to the cloud provider, you can either pay all of that money upfront, which will give you the maximum savings. You can do partial upfront, which means you pay some amount of that commitment upfront and the rest you pay on a monthly basis, or you do no upfront, where you only have a commitment to continue to use these services and resources, but you make the payments to the cloud provider month on month. So as you can imagine, just doing month on month payments with no upfront is the lower end of the savings. Doing maximum amount of that upfront will give you the higher end of the spectrum from a savings standpoint. Now, if you look at the highest amount that you can save is through what we've listed here called spot instances, right? Now, spot instances are essentially coming from cloud excess capacity. Now, to come good on the promise from cloud providers that anytime you want cloud resources, they're going to make them available to you. Naturally, the cloud providers have a lot of idle capacity in their data centers, right? So now to monetize this idle capacity, they make that available to customers through what they call as spot instances. So you're able to consume this idle capacity at significant discounts, 70 to 90% cheaper rates than your on-demand equivalent. But the catch there is availability, which means at a 2 minutes notice, they can take them away from you. But if you have the right kind of workloads, if they have a high availability setup, they're fault tolerant, and they're stateless, for example, you can leverage these spot instance pricing to save significantly on the compute costs. So there are various strategies that you can use to save purely from a pricing standpoint.
Okay. Thanks for the insights and some of the tricks. I know we're gonna have a demo soon. So Ravi, no matter which cloud provider we use, cloud resources come with a cost. So how to measure the cloud investment and justify them? Is there a formula or a tool?
Absolutely. So there are certainly benchmarks based on like industry, like the specific industries or the company size that one can reference, right, to see exactly how they're doing with respect to cloud spend among their peers, be it through the industry or company size. But really implementing some of the strategies that we just spoke about around like managing and cutting costs and ensuring that you're only spending what you need is really the best way to know that your cloud costs are where they should be. And we'll cover some of those in the demo shortly. So
Okay. So yeah, I think it's a demo time. Me and OP and all the viewers want to know, since you had the CCM team at Harness, can you show us how to track and make corrections with our cloud costs? That would be really amazing.
absolutely. So we can quickly jump into the demo.
Yeah, sure.
Yeah. Do you
Yeah, I
see
see
the
your screen.
overview screen?
Yeah.
I see your many
Uh,
paths to savings, that screen. Yeah.
Okay, still see that. Okay, let me just quickly share the window. Yeah, do you see
Yeah.
the
I,
overview screen now?
yes.
Okay, perfect. So, so let's dive into the demo of the tool itself, right? So this is the overview screen of the cloud cost management module within Harness. So as you know, like Harness, we have multiple modules. This is specifically the module to help manage cloud costs. So what
Okay.
this overview screen essentially does is that it gives you a high level overview of how your cloud spend has been over time. So you have the total cost across the last 30 days here for all of the cloud accounts that have been linked to this Harness demo account. You can see what the forecast is for the same cost over the same period of time into the future. You can see how the cloud and cluster costs have been trending over time. and you can see the total cloud cost by the different providers. So this is a sum total of all of the AWS accounts, Azure subscriptions, and GCP projects that have been linked to this harness demo account. What you can also see is a total of all of the clusters that have been that are part of all of the cloud accounts that are linked here, right? So and how efficiently these clusters are being utilized. So what you see here is a breakdown of the cluster cost through to three types of costs. So the first is the idle cost. So what this essentially means is that of all of the pod requested resources, whatever is unused is comprised of the idle cost, and the pod requested resources that are actually been used is the utilized cost, and the node resources that are not being allocated to any pods at all is your unallocated cost. So as a combination of this, we also calculate what we call as the cost efficiency score specifically for cluster spend. Now, this is a great view for you to get a high level idea on how efficiently your clusters are being utilized today. Now, of course, this is a view of all the clusters together, but we have the option to drill down as well. So here you can see here we have a list of all of the different clusters that are linked to this harness demo account. Right now, you can also see how the costs have been trending over time based on each and every one of these clusters. Now, what's also really interesting is what you see by default is the daily breakdown of costs, but we also have the ability to switch to an hourly breakdown. So if you go ahead and select that option here, so here you can see the exact cost tracking that's happening on an hourly basis across all of these different clusters, right? So this becomes really useful if you want to RSA into things like cost spikes and so on, so you can know when that actual cost spike occurred down to which hours granularity, right? Now, this view is actually showing you all of the clusters, how efficiently they've been utilized today through the efficiency score. But you can also drill down further here. So, for example, you can group this by namespace, by node, and so on, and also by all of the workloads that are running in these clusters. Right. So, for example, here see all of the different workloads that are running in these clusters. You can see the cost trend over time, which workload they are, is it a stateful set, a deployment, which namespace it belongs to, which cluster it belongs to, and so on. Now, not only can you see the total cost for each of these workloads, you can also see how much of that total cost is idle. So, for example, if you have a significant part of the total cost that is idle, you can also see out of that idle cost how much is idle from storage and from memory and so on. So, you have a really granular view into how efficiently these workloads are being used today. So, if we can go ahead and drill down into any one of these. So, here you can see, maybe we'll pick another example. So here you can see all of the request limits and utilization over time for this particular workload that's in this namespace, and that belongs to this particular cluster. Now, this is useful from a granular visibility standpoint, but what if you actually want to take corrective action based on all of the unutilized and idle costs across your clusters, right? How do you run what if scenarios and figure out what the impact might be if you're making optimization decisions? And that's where our recommendations come in. Excuse me. So we have different types of recommendations within CCM. The first type of recommendation that we have is around the workloads itself, right? So what you see here is a workload recommendation for this particular workload in this namespace in this demo cluster. And what you're essentially seeing on the screen is the current request and limit configuration for this workload, and what we recommend the request and limits configuration can be updated to, while satisfying all of the historical utilization requirements, but still saving significantly on cost, right? So what you see here is all of the historical utilization samples that we have, both across CPU and memory for this particular workload. And so when we're calculating these recommendations, you can either choose a cost optimized recommendation, which means it's more aggressive on cost, less on performance. It satisfies about the 50th percentile of all historical requirements, or performance optimized, which is taking into account the 95th percentile of all the historical utilization requirements that this particular workload had, which is more aggressive on performance, a little bit less on cost. Now, you can also fine tune these recommendations. By default, we have a burstable quality of service, but if you want the request and limits to match, you can have a guaranteed quality of service as well. And from a real world standpoint, maybe historical utilization is not enough as a baseline for the recommendations and for you to update the configuration of this workload. And so for that, we have this buffer option, right? So you can add, for example, let's say a 20% buffer on top of whatever historical utilization requirements this workload had, and then the recommendations would respect that as well, right? Um, so this is from optimizing the workload configuration itself. Now, it's not enough to just optimize the workloads, but also it's important to make sure that the nodes that these workloads are running on are optimized as well. So that takes us to the second type of recommendation that we have, which is on the node pool level. Right. So this is an example of that, where we have the current node pool configurations of which instance family it is and how many nodes it has, and what we recommend you can update that configuration to be, which instance family you can move to, and how many nodes. Again, here the requirement is the same. This is to satisfy all of the historical utilization requirements that you have for the workloads running on these nodes, while still being able to save significantly on cost. Now, again, here, just like with the workloads, we have ways to fine tune these recommendations based on your real world needs. Now, the first one you can fine tune is on the preferred resource requirements, which is pre filled based on the utilization data that we have, but these are fully editable. You can also configure buffers on top, just like you can at the workload level. And you can configure the minimum node count that you need, and also the largest workload requirements. These are all pre-filled based on the historical data that we have for this node pool, but these can be configured as well. Now, the last option that I want to talk about here is the ability to input preferred instance families. So let's say the recommendation that we show is really great from a cost standpoint, but for whatever real world scenarios on the ground, you're not able to actually utilize that requirement because you can't use a certain instance family. Right? So that's what this option allows you to do, is to input your preferred instance families, and all the recommendations that we provide will be restricted to that, and the recommendations will respect your recommendation preferences that you input here. And also, we have all the recommendations that you see on the screen available via APIs as well. And the examples that we just saw are for Kubernetes workloads and nodes. We also have recommendations for things like ECS services, EC2, and so on. So that is from a recommendation standpoint. I just like to take a quick pause here, Pawan, if you want to take any questions, or we can keep going.
Yeah, I think there is one question. All the recommendations are applied direct. Yeah, his name is Sudarshan. I see one question. If you want to take, or
Yeah,
at the
we
end
can
you want to take.
we
Yeah,
can take
he's
it.
asking all the recommendations are applied directly from the console, or we need to action against the recommendations manually.
Yeah, so both so basically the way you can consume the recommendations, and that's a great question, right? So there are a couple of ways you can consume the recommendations. So one way is to, for example, create tickets against this, right? So that's a way to use this as a repository for all the potential savings and the recommendations to achieve that, and create, for example, Jira tickets to track that progress and manually action them. Now, most of our customers who want to action this through having a lot of checks and balances in terms of approvals and so on, implement it this way. But there's also the ability to automatically leverage these recommendations, because, like I mentioned, we have first class API support. So everything that you see on the screen is something that we expose through APIs. So we also have customers who pull these recommendations in through APIs and actually automatically enforce whatever has been recommended here, both at the workload and node pool level. So both options are possible.
Yeah, thanks for the question, Sudarshan. If you guys have any questions, please ask, and we'll maybe answer them offline, or if we have time after the demo, we'll answer here only. Yeah, Ravi, you can go ahead.
Awesome. So the next thing that I want to talk about is a feature that we have called perspectives. Right. So perspectives are essentially a way to help teams track costs through various constructs. So these constructs could be by teams, business units, departments, and so on. Now, within perspectives, we have a bunch of out-of-the-box perspectives that you can consume. For example, the cluster perspective that we saw just at the beginning of the demo, or you have the ability to create custom perspectives as well. And this is a really useful tool for things like chargeback and showback and so on. Now, as an example of creating a custom perspective, so this is an example custom perspective that we have that tracks costs across all of the major departments in this demo account, right? So the first step to actually define the perspective is to define what cost you want to track through these perspectives. So these costs could be across AWS, GCP, and Azure, across your Kubernetes clusters, or through what we call as cost categories. Now, cost categories are essentially a way for you to manage and maintain the definition of these constructs. So we call them cost buckets. They again, they could be departments, business units, and teams, and so on. So once you create that definition of these constructs, you can consume them through these perspective reports. Right now, once we've defined what costs we want this perspective to track, what we essentially have access to, and this is the same custom perspective here, is not only do we have a granular view of how the costs that are important to us have been tracking over time, we have the total cost over time, we have the forecasted cost, we have the ability to configure budgets on top of these costs, and we also have recommendations on how we can reduce this cost. And all of these are relevant and contextual to only the costs that are being tracked by this particular perspective. So this is really useful from a cloud budget owner standpoint, where you get a high level view of how your costs have been trending over time, but also actionable recommendations, cost forecasting, budgets. And the third thing that you also get is anomaly detection. So essentially what we do is when from an anomaly detection standpoint is where we track your historical costs for the last, let's say, 15 to 60 days, and we forecast what we think your cost should be over time. And if your actual cost over that time is deviant from what we think it should be, we flag that as an anomaly. Right? And this is the dashboard that we have for all anomalies across this demo account. So the first example that you see here is 7 days ago, we found an anomalous spend of $1,500 that was almost 90% variant from what is typically business as usual, and that is for a particular BigQuery cost. Right. So this is how you would also automatically be able to keep track of anomalous cloud spikes on a real-time basis. You can get alerts of these anomalies through email, through Slack, and so on, without actually having to wait to look at the bill at the end of the month and try and figure out why the costs were significantly higher than before. Right. So this is available for all cloud providers across all different services, where we actually surface the anomalous cloud spikes in real time. Now, we saw the perspectives, which is really useful from a cloud budget owner standpoint, just to get a high level view and relevant information based on costs that are relevant to that team or business unit or department. But while that's useful for engineering and DevOps, from a finance, FinOps, CloudOps standpoint, a high level view is not sufficient, right? So there's really a requirement to slice and dice data, look at resource utilization, and so on. And so what we have with what we call as the BI dashboards is a lot more granular capability to slice and dice information. So here, what you're essentially getting is the full power and flexibility of a modern BI and analytics tool with your cloud cost information as the source. And just like the perspectives, you have a bunch of out of the box dashboards that you can consume for things like, say, often DBS volumes, snapshots, or your overall AWS costs or your cluster costs. But you also have the ability to create custom dashboards as well. Again, this is really useful for things like chargeback and showback. Now, we've spoken a bunch about all of the reporting capabilities, about the recommendations, and so on. Now, one of the key features that we have from an intelligent automation standpoint is a feature that we have called auto stopping. Now, auto stopping has been one of our most significant binary differentiators from the beginning, right? And what this essentially does is that it automatically detects whenever your non-production resources are idle, and automatically shuts them down, right? But what it also does is that it detects whenever new requests come in, it also brings up those resources for the end user in real time. So this allows you to save on the most granular windows of idleness throughout the day. Right. So what you see here is the overview screen for auto stopping, where you can actually track your total spend and savings over time as a percentage, and you can see how many active auto stopping rules are configured. And you can see in this demo account, for everything that we hooked up, we would have ended up spending $1,000, but we just end up spending $1, because, as you can imagine, these are very rarely used demo resources, but you can still expect significant savings of 60 to 70% on compute costs. And the way you would achieve that is really simple, right? So if you really look at, and this is designed for non-production environments, your demo, staging, developer machines. Now, if you look at lower environments, they're typically used for 4 to 5 hours on any given workday. right? So you have lots of idle windows within the workday itself, and then you have idleness on non-working hours, weekends, and company holidays. So if you look at the 4 to 5 hours of usage on a daily basis compared to the entire 720 hours in the calendar month, you're talking about 25-30% of the time when it's actually really in use, which means that 70-75% of the time it's absolutely idle. And that's what auto stopping allows you to take advantage of and make sure that you're not being charged by the cloud provider unless you're actually using them, right? And we have auto stopping support across AWS for things like EC2 VMs, ASGs, ECS, RDS, and EKS. On Azure, we have support for Azure VMs and AKS. And on GCP, we have support for Compute Engine VMs for GKE and instance groups as well. Now, as a quick demo of how this would work, this is an example of an auto stopping rule that we have. So as you can see here, this particular auto stopping rule, which is accessed through this domain, is currently in a stop state, which means that the VM is currently
Mhm.
down. Now, even though the VM is down, all we need to do to access it is anyway access the domain name or the URL that we would anyway access, even if auto stopping was not there, right? And we can see how this would behave. So this is a cached page. Just quickly refresh this. Yeah, so the moment you access it and the VM underlying resource is actually down, this is the progress page that you would first see, right? So what's happening here is auto stopping is detecting that this underlying VM is down, is bringing it up in real time, running a series of health checks, and then it will transparently forward the traffic, right? Now, if we come back here and refresh this, as you saw that before we click this, the rule state was down. If we go ahead and refresh this, now you can see that it's up and running. Now, all I did was go ahead and access the same URL, which means there's no change in behavior for the end user. Whatever URL they use to access it today, they will continue to access it. And then whenever it's idle, here you see this configuration called the idle time. Here we've set the idle time to be 5 minutes, but this is configurable. You can set it to any number of minutes. But what this means is whenever there is no network traffic in this example, whenever there's no access for 5 consecutive minutes, then auto
Mhm.
stopping will go ahead and automatically shut down this VM. But then whenever there is new access, it also brings it up for the end user in real time. So as you saw, like simply accessing it brings it up. And now if nobody accesses it for 5 minutes, it'll automatically shut it down. So again, you're able to save on the most granular windows of idleness using the auto stopping feature. So I'd like to again take a pause here if there's any other questions, Pawan.
Yeah, there are two. One is is this cost optimization of K8s workloads only?
Yeah, so this is like, for example, this particular example is optimization of a particular VM, right? So we have optimization for all types of cloud resources, whether it's standalone VMs, Kubernetes, etc. So we support all services across all the three major cloud providers: AWS, GCP, and Azure.
Yeah, there is one more. Though this cloud and DevOps is new to me, but listening this, does this tool indirectly does the performance engineer work?
Yeah, so what we're essentially trying to do here is to provide all of the tooling required to effectively manage cloud costs across the three pillars that we spoke about. So giving a clear view of cost reporting, like who's spending what, and giving the visibility into cloud costs. Then the optimization, giving you different automation and recommendations to cut costs wherever is possible. And the third is on cloud governance, to use things like budgets and forecasting and cloud governance to make sure that the costs are governed and have all of the relevant checks and balances in place. So all of that tooling in one single cloud cost management module.
Yeah, those were the two questions.
Perfect.
The
So
demo is
yeah, so
still
that
there.
was yeah.
Yeah,
So just we have a couple more things that I like to cover. So everything
yeah,
that we covered so far is what is already available in Harness today. Now I'd just like to spend a couple of minutes on some of the new beta features that we've just released, right? So the first one that I'd like to cover is what we call as the cloud asset governance. So this is a really useful way to actually automate the enforcement of different rules or policies, right? And this can we currently have beta support for AWS, and we'll expand this to other clouds soon as well. And this can apply to any service on any kind of AWS service, and you can perform various types of actions as well. So, for example, you can see here of all the ways you can action for RDS databases. And as a quick example, uh, we can take a look at this one where you're actually this particular governance rule is tracking all the unused RDS databases over the last 7 days and using a webhook to actually go ahead and create a Jira ticket. right? Now the actions can be as powerful as using a webhook to perform any downstream action, like creating a Jira ticket or actually take actions, or as simple as just listing out whatever the output is, right? So these kind of rules can be created and enforce the automation for it across any kind of AWS service today, and we'll expand the footprint to other clouds as well. And once you selected what kind of rules you want to consume, you have the enforcement, which will actually schedule the running of these particular rules, and then you can track the output through the evaluations. So again, this can be extremely powerful from a cost management and compliance standpoint, to make sure that there is automation to take care of all of the different cloud services that are being consumed. And the second thing that I'd like to also talk about is on the finance and FinOps side, based on the commitment instruments that we spoke about, like the RIs and savings plans. So for this, we have a feature called the Commitment Orchestrator that's just out in beta. Again, this is available for AWS to begin with. So here, what you have is two parts. So the first is granular visibility into all of the commitments that you have today. So be it RIs or savings plans. So here you can see the total compute spend that's linked to this harness demo account. Out of all of that compute spend, how much is covered by savings plans, how much is covered by RIs, and how much is continuing running on demand, and what is the savings that you're realizing so far, right? And you finally can see all of the utilization of the commitments that have been purchased. So meaning, for every $100 worth of spend, how much of that is actually covering compute and resulting in savings, versus is there anything that is overcommitted and ending up in wasted spend. Now you can also see more granular views for each of these numbers. But one of the really interesting parts of this is the second part of the value proposition, which is the orchestration, which essentially means that on your behalf, this feature will automate the purchase and management of these commitments, right? So multiple times a day, it will take actions on your behalf to not only maximize the compute coverage across all the compute that we have using commitments, but also to maximize the savings. And it does this through a combination of compute savings plans and convertible RIs, where we're using one type of instrument to cover your steady state spend of compute over time, month on month, and another type of spend to cover your ad hoc spend, like the part of your compute spend that goes up and down every month. We use a combination of compute savings plans and convertible RIs to maximize your savings and maximize the compute coverage. Now, the last feature that I'd like to also touch upon in this demo is another beta feature that we have, specifically that we've released in beta for EKS, is called the Cluster Orchestrator. Now, at its core, the cluster orchestrator is essentially an effective autoscaler for EKS, right? So if you look at what is natively available with Kubernetes, like with things like HPA and PPA, those are really useful features which essentially increase and decrease the size and count of pods based on incoming demand. Now, while that's really useful from a workload standpoint, the challenge becomes when the native Kubernetes autoscaling tries to match these dynamic workload changes with acceptable nodes, right? Because if you're either spinning up the wrong kind of node, or you're taking down the wrong node from the set of existing ones, the result is the same, and you end up with unscheduled pods that are in a pending state, right? And so at the core of it, that's what the cluster orchestrator is trying to solve for, making sure that the right kind of nodes are spun up and down based on workload requirements. And that's why we call this workload driven intelligent autoscaling. Now, while that's at the core of the value proposition, the real cost savings with this feature comes from the spot orchestration, right? What that essentially means is that you're able to run your workloads using the cluster orchestrator for EKS on spot nodes, right? And the orchestration that we have built in is, whenever there's a spot interruption, we automatically fall back temporarily to an on-demand node, right? Even before that, what we do is we try to provision an alternate spot in its place that has enough capacity and the least likelihood of future interruption. But if there's no capacity, we fall back to on-demand temporarily. And the moment capacity is available again, we fall back to spot, so that you're able to leverage that spot pricing without having any availability issues, right? So this is the base spot orchestration, which is really useful for spot-ready workloads that have high availability, fault tolerance, and if they're stateless. But the key differentiation that we have in this product is that you can also run your critical workloads that you don't want to associate with any kind of spot interruption. You can leverage spot pricing for. And the way we can do that is what we call as distributed spot orchestration, right? So what this essentially means is that for any given workload that have a bunch of replicas, you can run a few of those replicas on spot and a few of them on demand, while also configuring what we call as a base on-demand capacity that will guarantee a number of replicas that will only run on on-demand nodes. So with this kind of safety in place, you can also leverage spot pricing by just running a few replicas for that particular workload on spot nodes. So this is really useful even for critical save and production workloads as well. So again, these are some of the beta features that we wanted to cover. But that was a quick overview of all of the different CCM capabilities that we had. And yeah, back to you, Pawan. You can take any questions if
Yeah,
there are.
thanks for the demo, and it was really helpful. And some of the features I liked, like the recommendation part, showing anomalies, budget forecasting, creating custom dashboards, the auto stopping, etc. I mean, there's much more with CCM. So hey guys, if you guys are watching, please navigate to app.harness.io, sign up and try the CCM module to manage your cloud costs from today. And there is one more question, no, OP? There
Yep.
is one question from
That's
Sudarshan again.
Sudarshan.
Yeah. So he's asking, is there any way we can create custom cost dashboards for individual business unit or to
Absolutely.
visualize cost for?
Absolutely. So, give in the interest of time, we did a very quick demo. But basically, with the feature that we have called cost categories, and there's public documentation available about this. So that's how you can actually define and manage the definition of your business units or orgs, right? So let's say your orgs are using a certain number of Kubernetes clusters, or even a namespace within a cluster, or particular AWS accounts, Azure subscriptions, or GCP projects. You can make those definitions of like which business unit or org is consuming what kind of cloud services or resources, and then you can actually have either perspectives or custom dashboards based on the definitions that you create. So that's fully possible on CCM.
Sure.
Yep. So I think we are almost at the end. There are no more
Yeah.
questions, and yeah, even if there are any, we can take it offline.
Offline.
So
Yeah.
thank you again, Ravi, for being so friendly and showing us a demo of a user-friendly tool. I hope this will benefit developers by helping them to save on cloud cost spend. So thanks for joining, everyone. Hope you enjoyed our show, and we'll keep you updated with our next show date and time. Till then, take
Yeah.
care and happy hacking.
Bye bye. Thanks, Ravi. Thanks. Thanks,
Thanks.
guys. Bye bye. Bye bye.